Example 5. Find the real zeros of f. Use the real zeros to factor f. Our polynomial function is f of x is equal to 3x cubed minus 7x squared plus 12x minus 28. All right, so we're going to follow the procedure outlined on page 4. Okay, so we are going to start, if we flip back to page 4, we're going to determine the degree of the polynomial function to determine the maximum number of zeros. So here, this is a degree 3 polynomial. Okay, so polynomial is of degree 3. So there are at most 3 real zeros. Okay, remember what I told you back in example 4? When you're doing these polynomials of a higher degree, the degree indicates the total number of zeros split between the real zeros and the imaginary zeros. Okay, and when you're looking at real zeros, the multiplicity factors in. Okay, so here we've got to have 3 zeros total, essentially split between the real zeros and the imaginary zeros. Okay, all right, next step, back on page 4, we're going to use the rational zeros theorem to identify the potential rational zeros. Okay, all right, so this is going to be the P over Q thing. Okay, so in step 2, we need to identify the potential rational zeros. Okay, and we're going to make our list. It's going to be plus or minus P over Q. Okay, so the P is referring to the factors of the constant term. Okay, so basically this is going to be, the numerator is going to be the factors of 28. Even though 28 is negative, you don't have to worry about the negative sign. The sign is going to be taken care of with the plus or minus. Okay, so just take the number with you. The bottom is going to be, the Q is referring to the factors of the leading coefficient, which is 3 here. Okay, so this is going to be the factors of 3. Okay, that's your leading coefficient. Okay, so let's go ahead and write these guys out. So remember, we're going to have a whole list of numbers. Each one of those will have a plus or minus out front. I'll do that in the final list. Okay, the factors of 28. What numbers, what pairs of numbers do you multiply together to get 28? Okay, well, 4 and 7 for sure. And then you've got 2 and 14. And then you've got 1 and 28. Okay, so those are all the factors of 28. The bottom is going to be the factors of 3. The only numbers that you multiply together to get 3 are going to be 1 and 3. Okay, so now we can generate our list. Okay, so I'll do my little rough draft and then I'll clean it up after. Okay, so again, I'll put the plus or minus out front. I'm going to do it systematically. I'm going to take every number in the numerator and divide by every number in the denominator. Okay, so I'm going to start with my 1. Okay, we're going to divide it by both 1 and 3, the numbers in the bottom. Okay, so we're going to get 1 over 1, 1 over 3. Okay, then we jump to 2. Okay, we're going to take the 2 and divide it by 1, and then take the 2 and divide it by 3. Okay, moving on to the 4. We're going to divide it by 1, and then divide it by 3. And then we're going to go to the 7. We're going to divide it by 1, and 7 divided by 3. Okay, then we go to the 14. We need to divide it by 1. We need to divide it by 3. Okay, then we need to take the 28 and then divide it by 1 and then divide it by 3. Okay, so again, when you do this, you of course get some duplication, so we clean it up. Okay, so here will come my final list. I'm going to put plus or minus. I'm going to go through the list and simplify and mark out duplications. Okay, 1 divided by 1 is going to be 1. Okay, so we've taken care of this. If there's anything else that reduces to 1, I'm looking for it. I don't see anything. Okay, so then we've got plus or minus 1/3. Okay, so this has been handled. I'm just looking for anything that reduces to 1/3. Okay, actually, I don't think we have any duplications here. Okay, I don't think we have any duplications. Okay, so we're going to have plus or minus 2, plus or minus 2/3, plus or minus 4, plus or minus 4/3, plus or minus 7, plus or minus 7/3, plus or minus 14, plus or minus 14/3, plus or minus 28, and then finally plus or minus 28/3. Okay, that's a lot of potential rational zeros. Okay, we know this is way too many zeros. We know we are dealing with degree 3, so there are at most 3 zeros split between the real numbers and the imaginary numbers. Okay, so these are just potential x-intercepts or zeros. Okay, all right, moving on to step 3. Okay, in step 3, you need to look at the graph of the polynomial function, okay, because we're going to have to start doing the synthetic division because ultimately we want to factor this polynomial as well as find the zeros, okay? So we have to have a starting zero. The graph will help us, okay? So let's take a look at our picture. Like I said, I will provide one for you, but when you do your homework, you're going to have to look at a graphing calculator, okay? So what we're doing here's the graph of the polynomial. I found a good window for you, and it looks like there's just one x-intercept, okay, or 0. So it's right there where the x is, and it's occurring somewhere between 2 and 3, okay? So we're dealing with a positive x-intercept. So we've got to start our synthetic division somewhere. Which one of these guys that I have in the box here, which one looks like it is, between 2 and 3? Okay, well, it's going to be one of the fractions. Okay, 1/3 is less than 1, 2/3 is less than 1, 4/3 could be it. Okay, well, no, actually, 4/3 is 1 and 1/3, so it's between 1 and 2. 7/3, let's look at the calculator. So if we look at the calculator, 7/3 is going to be between 2 and 3. Okay, and then I think the next fraction we had was 14/3. It's bigger than 4. Okay, so it looks like this could potentially be in this picture. This 0 that I have marked with the X, it looks like this is going to be 7/3, but we've got to be sure. Okay, so that's what we're going to use as our starting point in our synthetic division. Okay, so let me go ahead and write down for step 3. We looked at the graph, and x equals 7/3 appears to be a 0. Okay, so now in step 4, we will start the synthetic division. Okay, you could also, test this out. You could take 7/3 and plug it into the polynomial to make sure you get 0. That will be indicative of a 0 remainder. Okay, but remember, doing the synthetic division, it's going to help you, it's going to get you further in the long run. It's going to help you get towards your goal of factoring the polynomial here. Okay, so let's start with the synthetic division. We're going to set it up. We need to go back to our original polynomial function. We are starting at degree 3. Nothing is skipped. We go from degree 3 to 2 to 1 to the constant. So we're just going to write down the numbers that we see. Okay, so if we set this up, there is a 3 in front of x cubed, and then there's a -7 in front of x squared. Then there's a 12 in front of x, and then the constant is -28. Okay, so that's what goes here, and we have to put a number out front. And remember what goes there. That is going to be the number that we think is the 0. We think it's 7/3. Okay, remember, if this does indeed produce a 0 remainder, the factor is going to be x minus 7/3. Okay, make sure you understand going between the 0 and the factor. Okay, so this is how you're going to set it up. Okay, so let's do the synthetic division. We're going to bring down the 3 to begin with. Okay, so then we multiply. 3 times 7/3 is going to give us 7. Okay, and then we add this way. -7 plus 7 is going to be 0. And then we multiply. 0 times 7/3 is going to be 0. We add this way. So 0 plus 12 is 12. And then we're going to multiply 12 times 7/3. Okay, this is going to give us, let's see, 3 goes into 3 one time, 3 goes into 12 4 times, 4 times 7 is 28. Okay, so that's going to give us positive 28. Negative 28 plus positive 28 is going to give us 0. Okay, so we have a 0 remainder. Okay, so this confirms that x equals 7/3 is a 0 or x-intercept of our polynomial function. Okay, so I'm going to go ahead and put this in the box. X equals 7/3 is a real 0 of the polynomial function. Okay, all right, so this means that if you have x equals 7/3 is a 0, that means x minus 7/3 is a factor. Okay, so if we start factoring here, okay, I'm going to write down this factor of x minus 7/3. Okay, all right. The great thing about synthetic division, it's going to help you out with the rest of the factoring. Okay, so we got our 0 remainder. Okay, that means that x minus 7/3 is going to be a factor. The other factor is going to lie in the bottom row here. Okay, so remember our original polynomial started with x cubed. Okay, so in the bottom row, to read off the other factor, you're going to go down by a power. So it's going to be 3 times x squared plus 0 times x plus 12. Okay, so the other factor here is going to be 3x squared plus 0x, so I won't write that down, but plus 12. Okay, all right, so let's keep going here. Okay, let's work with the factored form and then we'll address the zeros. Okay, we need to factor completely. Okay, we need to factor until no part of this factors any further. Okay, there's nothing at this point that I can do with the x minus 7/3. However, if you look at the 3 times x squared plus 12, there is something common to both of these pieces. You can take out a 3. Okay, so I'm going to leave the x minus 7/3 alone. Okay, but I'm going to factor out a 3 from the second factor. If I take out a 3, I'm going to be left with x squared plus 4. Okay, and now there's nothing common to these two pieces. Okay, all right, so let's see where we are. Okay, let's kind of regroup. Okay, all right, we cannot factor we can't factor x minus 7/3 anymore. We can't factor 3 anymore. Can you factor x squared plus 4? Well, if you know your factoring techniques, you can factor a difference of squares. Okay, x squared is a square. You square x to get x squared. And 4 is a square. You square 2 to get 4. Okay, if this thing were x squared minus 4, it would factor. It would factor into x plus 2, x minus 2. However, we have a sum of squares. We are adding here. Okay, if you are adding squares, you cannot factor. Okay, so because we have a plus sign and not a minus sign, this does not break down any further. Okay, this is as far as we can go on this factor. Okay, so we're essentially done. Okay, now I do want to mention one thing. Okay, typically if you look up your answer like in the back of the book, you won't see this. Usually you won't see a factor that has fractions. Okay, the 7/3 is kind of like not wanted. It's not incorrect, but it's preferable to write the answer without a fraction. So what you can do is you can take this 3 and you can send it through here. Okay, remember, when you multiply 3 things together, if you just had 4 times 5 times 6, you multiply them 2 at a time. You would do 4 times 5 to get 20, and then you'd multiply by 6 to get 120, and you'd be done. You're not going to distribute the 3 to both factors. So what I'm going to do here is I will choose it to send it to this factor with the fraction. Okay, so if I distribute it here, it's going to be 3 times x minus, okay, 3 times 7/3. That's going to give us 7. Okay, so we've combined these two guys, and then we've got the x squared plus 4. Okay, so this is the preferred way of expressing the factorization right here. Okay, so this polynomial, okay, the original polynomial, 3x cubed minus 7x squared plus 12x minus 28, it factors into 3x minus 7, that quantity, times x squared plus 4. Okay, all right, so we've got the factorization down. Let's discuss the zeros. Okay, so remember, how are you supposed to get the zeros once you have the factorization? Well, you need to take each factor, set it to 0, and solve. Okay, so we have two factors here. We have 3x minus 7. We're going to set that to 0. Then we have x squared plus 4. We're going to set that to 0. Okay, we're going to solve each one of these. Okay, so here I'm going to move over the 7. So I'm going to get 3x is equal to 7. Divide both sides by 3. Okay, that's going to give me 7/3. We already knew about that one. Okay, we already have it written down. And in fact, if we look at our picture, we were pretty certain that the one I had marked with a red X was the x-intercept x equals 7/3. Okay, when you look at your picture, you don't physically see any more x-intercepts. Okay, the graph crosses at x equals 7/3, so it's going to have an odd multiplicity. But we do need to go and look at the other factor. Okay, we need to take x squared plus 4 and set it equal to 0 and solve. Okay, so subtract 4 from both sides. You're going to get x squared is equal to -4. You've got something squared equal to a number, so you can take the square root of both sides. Okay, this is going to tell us, like, if you have the square root of x squared is going to give you x. Okay, and then you've got the square root of -4. Okay, so this is an imaginary number. Okay, so we're going to go a little further here because we're going to start working with imaginary numbers more so in the next section, but I want you to be prepared for it. Okay, we're going to break this down a little further. Okay, this is going to be, you can rewrite -4 as -1 times 4. Okay, since they're multiplied under the square root, you can break them up. This is going to be the square root of -1 times the square root of 4. Okay, the square root of -1, this is important, is called I. It is the imaginary unit. Okay, square root of -1, square root of -1 is I. Okay, you need to know this. This is the imaginary unit. Okay, so the square root of -1 is going to be I, and the square root of 4 is going to be 2. Okay, so this is really 2I. Okay, now I forgot something. Remember, when you have something squared is equal to a number, you have to have the plus or minus out front. Okay, so I forgot that, so let me carry it through. Okay, this needed to have plus or minus. Okay, so you end up with two imaginary zeros. Okay, you have positive 2I and then negative 2I. Okay, so you have a total of 3 zeros. Okay, we have one real zero, okay, which is x equals 7/3, and then we have two imaginary, okay, positive 2I and then x equals -2I. Okay, these are two imaginary zeros. Okay, the question did ask you only for the real zero, so you really only needed to give 7/3 as the answer, but I wanted you to be aware, since the degree is 3, you should have 3 zeros, and here they are. There's one real of 7/3 and two imaginary zeros, 2I and -2I. Okay, so here is how you do this problem. Okay, again, if you had to write down the answer, what I have in the red box right here is what you would write down for the factorization. Okay, and then you would only be responsible for stating the real zero. Okay, and there's only one, which is x equals 7/3.